We have now with us Cong, who's product manager with Jinko. He's responsible for the N-type series modules and the BIPV sector. So we're very excited to have Leo with us.
Hello, Michelle. Can you hear me?
Yes.
Okay, I will share the screen now. Okay. Can you see it clearly?
Yes, absolutely.
Okay, then I will start my presentation now. Okay, hello everyone, nice to meet you here. This is Leo Cong from JinkoSolar, and I'm glad to have this chance to share our high-power product, Tiger Pro N-type series with you. My presentation title is Tiger Pro 610-watt model, the perfect combination of innovative HOT 2.0 technology and high power. Jinko's Tiger Pro N-type model with top Cong technology has been developed out of the necessity to provide a premium solution for current market. It represents an evolution of the previous PERC technology as it combines three advanced technologies: the N-type top Cong cell, the multi-bus bar, and half cell. These technologies improve motor power and efficiency, offer a lower temperature coefficient, better operating temperature, and better LETID degradation, leading to higher power generation. It also holds an extended 30-year power warranty, combining the benefits for the current market. It can significantly reduce both costs on space and installation side, ultimately driving higher IRR and lower LCOE. Now I will start my presentation and share more detailed information with you. Firstly, our high-efficiency N-type cells. Solar models are our principal products, as solar models are priced, based on the number of watts of electricity they generate. The advancement of manufacturing technologies in increasing the conversion efficiency of solar cells and production efficiency will enable us to improve our gross profit margin. We continuously make efforts to develop advanced manufacturing technologies to increase the conversion efficiency of our solar cells while striving to reduce our average production cost. In addition to our own research and development team, we collaborate with third-party research institutes also to improve our manufacturing technologies and the conversion efficiency of our solar cells. As a result of these efforts, the continuous breakthrough of our N-type cells is as below. The mass production efficiency reached 24.15%, while the lab cell efficiency record broke 24.9%, which was set a world record for large-size contact passivated solar cells. Of course, I listened to the whole presentation carefully, and Longi broke the record again to 25% this year. Congratulations, and thank you for your contributions to the breakthrough of N-type cells. Hope that with Jinko and Longi will have more chance to talk about and collaborate to increase the cell efficiency and make contributions to PV industry together. This is a brief comparison of traditional PERC, top Cong, and HID cells. Briefly speaking, to introduce a new technology or develop a new kind of product, many factors have to be taken into consideration. Take our Tiger Pro N-type model as an example. Top Cong roots are highly compatible with current equipment, while the efficiency is significantly improved compared with that of traditional ones. So comprehensively consider the initial product investment, the return expectations. This product would be an excellent option. To be more specific, the N-type Tiger Pro series with higher power, higher efficiency, lower degradation, and modified bifacial factor is expected to be the most potential product in the future. The evaluation of future N-type market share is also expected to gradually take up a large proportion. As you can see on screen, this is a brief product review of JinkoSolar. In October 2019, we launched a new high-efficiency Tiger model using 9-busbar monoPERC and tiling ribbon technology with model efficiency of 20.9%. The new Tiger model is capable of generating up to 470 watts of peak power output, which makes it suitable for both utility and rooftop installations. In May 2020, we officially launched our 2020 flagship Tiger Pro model series. The model series could generate a maximum power output of up to 580 watts, which was 30% higher than current mainstream products installed in utility projects. All these high energy density models used innovative multi-busbar and TR tiling ribbon technology to reach significantly improved performance with a conversion efficiency of up to 21.21%. And now, our new generation of 610 Tiger Pro high-efficiency monocrystalline TR solar model is also ready to step into the public, which will be presented at SNEC 2021 in Shanghai. Here are the basic information of our 610-watt Tiger Pro N-type model. The 182 HOT2.0 cells, the tiling ribbon technology, the multi-bus bar, the 78 half-cell design, and the improved bifacial factor. All of these will contribute to the model with both maximum model power and efficiency. And you can see the real model in the SNEC exhibition venue. I think that you will have the surprise. Then I will share more detailed information with you. Firstly is the efficient passivation contact technology. This technology is applied in our HOT 2.0 cells, which updates the micro-tunneling through the oxide layer and carrier selective lamination of monocycline silicon thin films on the rear side. This advanced structure will contribute to better passivation performance and electrical conductivity, increasing the cell efficiency and power generation performance. Under the current production condition, the N-type HOT 2.0 cells maximum efficiency is close to 25% and has a broad application prospect in the near future. As shown in the left side, the maximum cells efficiency is influenced by a selective factor. Let's just call it S10 here. It is determined by two main parameters, the J0 connected to the majority carrier and the rho C to minority carrier restraint. This is a brief explanation to the much higher efficiency limit of HOT 2.0 cells. When it comes to the power part, the half-cell technology, the tiling ribbon, and the multi-bus bar will make great contributions to the increase of model power. To be more specific, the multi-bus bar decreases power loss effectively. The half-cell improves shading tolerance because of splitting a full cell into half. By using half cells, the electrical current flowing in each bus bar is halved. Therefore, the amount of internal losses in a half-cut model is around a quarter of a full-sized cell. The shading loss of half cell is much better than normal model in certain shading conditions. The tiling ribbon eliminates cell gap to increase the model efficiency also significantly. The use of circular ribbon and the overlap on each cell to eliminate the gap. Here, is the real loss analysis of both the electrical side and the optical side under different busbar combination. When the busbar increases by 1, the internal resistance of the model decreases by about 4%, and the corresponding power increases by 0.18%, and the power loss is 0.11%. We also made a conclusion, and as you can see, the overall power loss situation is also summarized here on the slide. The dashed lines represent combinations that are less manufacturable. We took yield, cost, and many other important factors into consideration. The number of busbar and the size of ribbon are closely related to the performance of the model, and the optimal performance can only be achieved by selecting the appropriate size of the cell. Also, combined with electrical, optical losses and manufacturability, the 10 busbar and the 0.35 millimeter circular ribbon is the optimal solution for 182 wafers. Then, comparing with traditional 5 busbar normal ribbon, Jinko circular ribbon has better suppleness. After the pressing process, it performs excellent reliability. Tiger Pro series has been developed by Jinko R&D independently to achieve the reutilization of light absorption and increase energy generation. According to the experiment, specially made materials will fill the overlapping region that gives excellent buffering effect to ensure the reliability, which therefore increase the model efficiency around 0.4%, and the power generation about 1.57%. Besides, as you can see in the picture and the table here, when the incident light is oblique, the comprehensive light utilization rate of normal ribbon is about 10% lower than that of circular ones, and the corresponding power generation is also reduced, which will affect the revenue of customers. So with the bifacial factor, the back of the normal ribbon is flat, as you can see in the left picture, and the bifacial factor of the product is about 2.4% lower than that of the conventional half-cell ones. In addition, Jinko 610-watt high-power model uses transparent backsheet design from the view of physical parameters. With the rising of the model size, the weight difference between transparent backsheet models and the dual glass models increases. By using transparent backsheet, the model weight could be controlled within an optimal range, which will bring installation convenience for handling equipment, transportation, and reduce the cost of tracker system. Considering the power generation, the transparent model also has better performance. The power generation and radiation data were fitted here with a first order function. The slope of dual glass model is lower than that of transparent model. To be more specific, under low irradiation conditions, the generation performance of transparent model is slightly better than bifacial ones, while under high irradiation conditions, this advantage will be further enlarged. Then you can see the warranty that I mentioned above of Tiger Pro N-type series is also modified. The 30 years power warranty and the 15 years product warranty will bring better customer experience and more comprehensive services. From sales side, the first year degradation 0.1% and annual degradation from the second to the 30th year 0.4% will also have positive effect on the power generation performance. If you are interested in the detailed electrical performance, we can also share more detailed data and simulation results with you. Then compared with P-type products, N-type cells applied with different doping technology perform better in power degradation. The significant increase of our bifacial factor and the optimization of operating temperature also bring higher power gain. The advanced N-type HOT2.0 technology brings better temperature coefficient from the P-type, the minus 0.35% to minus 0.34% of N-type cells. N-type efficient cells optimize the operating temperature also, resulting in better model power generation performance. Also, the low boron content in N-type crystal silicon significantly lower air ETID from the 0.9 to 1.2% of P-type to 0.4% of N-type cells, and that will improve their ID to lower than 0.5% also. When it comes to the LCOE value, the analysis result has been markedly reduced compared with traditional P-type models. I think that many other presenters have shared a lot about LCOE analysis, and I will share with you from Jinko side. As you know, LCOE can combine both the fixed costs and variable costs into a single measurement to simplify the analysis to help firms determine the benefit, how much electricity it will produce, and the input costs, and whether to move forward with a project. Here is, on the left side, is actual project data of Jinko Tiger Pro N-type 610 watt model. As summarized on the right side, the power generated is raised by around 3% due to all the important factors that I mentioned about the high efficiency N-type cells, the circular ribbon, the modified LE, TID, and LID, and all other factors. The saved land cost, mounting area, and installation cost, and therefore the decrease of both around 2.3% also contribute to better LCOE. The increase is about 4.9%. What's more, the ribbon resistance will also increase under the reduction of its cross-sectional area, resulting in a relevant increase in the string resistance of the model. Finally, the Tiger Pro N-type model performs also well with different trackers and inverters. No matter the fixed mounting system, the one portrait tracker, or the two portrait ones, no matter the string, inverter, or the central ones, the excellent compatibility of this product could meet various demands with optimal performance. Today, my presentation focuses on the Tiger Pro N-type 610 watt very high power model. In the formal exhibition venue, we will also bring many other excellent products. For example, the mainstream 182 traditional PV models for DigiMarket, the new generation of PV extended products, like, for example, the BIPV series. And I believe that our new products launched by Jinko at SNEC exhibition will give you a big surprise. These are all the presentation content of Jinko 610 watt Tiger Pro N-type series. Thank you all for listening.
Thanks, Leo. Very, very interesting. Great to see this TopCon presentation. Can you give us a little bit background also on your TopCon capacity and your expansion plans? So how much of, because Jinko has pretty big capacities, how much of that is TopCon this year, and what are your plans for this high efficiency technology?
You know that the N-type cells, we have various, model series of N-type models. And if you mean the N-type cells capacity, I think that is 800 megawatt. Yeah, it's about this number. Just can give you directly the number.
Okay, that's nice. And are there already some rollout plans for expansion? I think that's pretty impressive when you start already. So what's your roadmap for N-type also in terms of production shares? Can you share that?
Okay. If you mean the N-type model, you mean no matter the smaller size or the
any N-type modules at Jinko. So what kind of role does it play in the near future?
Okay, till now that our N-type model is mainly the Tiger 163. I think this is mainstream for utility product, and the N-type monofacial. No, it's for Digimarket, mainly for Digimarket. The Tiger N-type 163 is like 60 and 66 TR. This is our current mainstream product for Digimarket. And I think as you see the Tiger Pro 610 watt model that I introduced today, the mass production might be 2022. And I think this is our plan for all the N-type models, if you mean the mainstream model.
Okay, and what about when we look about N-type large-scale wafers, so M10 wafers? So what is the availability? Are you doing that? There's a question. Are you doing that in-house actually? Is this your own wafers you're using for this? Can you share that, or?
Well, that's my private opinion, and no matter from the system matching degree side or the economy, the 182 would be, I think, in my own opinion, is a better choice currently. So I think that if you need an answer, that Jinko now focus on the 182 more, and I think that 182 will cover the whole 2023. In my own opinion, it will cover the demand.
No, but also for your N-type products. So that will be also 182.
Yeah, it will be 182. And you can see that we will have the 182 N-type, no matter for the utility and, maybe for the Digimarket, we will also have new model series, and you can wait for the Jinko. And I think that our new products will give you a big surprise.
Okay, very interesting, very interesting. I think, yeah. So I think that's great. I think I would love to go to SNEC to see the products. Unfortunately, I cannot, but everyone who can, I advise to do so. If you can stay for a few more minutes here and actually see if there are any questions also in the chat you might want to answer, that would be great.
Yeah, of course.
Okay, Leo.
Okay.
Thank you so much for this wonderful presentation.